Hello and welcome to SudoKanard. We're here to solve this Renban Sudoku from Sudoku Grand Prix by Thai author Sakulbuth Ekvittayaniphon. Sorry if I mispronounce your name. This was a quite difficult puzzle. Actually, when I tested the round, it was the puzzle from it was the puzzle that took me the longest time. So the rule of Renban Sudoku is that in all of these T-shaped regions that are shaded, we have a set of different digits that are globally consecutive. For example, we could have, say, 9, 7, 8, 5, 6, which is 4, 5, 6, 7, 8, 9 in any order. It could actually very well be the exact list of digits. I don't know about that. I don't remember. Okay, and you can see this remarkable visual theme of letters T, even T-shaped Tetris pieces, which is always nice. And so let's try to solve this. So something you have to appreciate with a Renban region of size 5 is that it will always contain digit 5, because the minimum value would be from 1 to 5, the maximum value would be from 5 to 9. In all cases, you need a 5. And for example, you will have a 5 in here, like this. Regarding this region, this Renban, it does not contain a 3. So it's either digits from 4 to 9, no, sorry, from 4 to 8, or from 5 to 9, so it will always contain 5, 6, 7, and 8, which means that 1 and 2 are not in those cells. So 2 will be around here, and 1 will be in one of 3 cells. Okay, I don't think I can do better than that at this point. But I'm also seeing that 2 is not in those cells. So in this region, 2 will be there. And in this column, 2 will be around here. Not sure I can do more with that. Oh, 2 and 3 are around here. This is more interesting. I hope. Hopefully this is more interesting. Now 3, as I mentioned, is not in this, but 3 is also not in this. So this Renban group is also either from 4 to 8 or from 5 to 9, and it contains an 8, which is not in here, so 8 is there. And an interesting point is that this digit here is different from all of those. And as I mentioned, all of those contain 5, 6, 7, and 8. So this is different from 5, 6, 7, and 8. And it can only be a 4. Oh, nice. I don't remember thinking of this earlier. So the Renban group here is actually from 5 to 9. So this is 7, 8, 9. Those are from 6, 7, 8, 9. And this digit, which is in none of those cells, will have to appear somewhere there along with 1, 2, with 1 and 2. Nice. And this, that's interesting. This is either from 4 to 8 or from 5 to 9. So it will contain exactly one of those two digits, and this digit will be somewhere here. Those are from 5, 6, 7, 8. this is from 5, 6, 7. And this digit here sees all of them, which means that this is different from all of those digits, so it's different from 5, 6, 7, 8, and those, so it has to be a 1. I have absolutely no memory of this logic, and it prevents this from being a 1, so this here is a 1-2 pair. And this digit here is one of them here. It's not an 8, so this is from 5, 6, 7. And this digit has to appear somewhere in there. And it's different from all of those, so this digit must be the same as this one, and the only possible value is 7. So that's not 7, and this 7 must appear in this Renban, so it must be somewhere there, along with 4 or 9. So there is a 7 in here, and those are from 4, 7, and 9. And those are now 5, 6, and 8, and I can remove this little 8. Nice. 2 goes there. This digit will be somewhere in here, and also the missing digit from 4 and 9, and 3. But we don't know anything more about 3. This 4 is nowhere in here, so the only possible value for those is, again, digits from 5 to 9. 5 is not here, so 5 will be there. So this is not 5. And 5 and the second digit here are not in here, they are not in here, so they must be there, which means that the other digit here is not a 6, it's not an 8, so it's from 7 and 9. Those are from 5, 7, 9, and there is a 5 among them. And the other digit here is 7 or 9, so this is 5 or 9, this is 5, 7 or 9. We have the 6 and the 8 around here, so 8 is in one of those two cells. 8 is not in here, so it will be in one of them. And the other two digits are 4 and 9. Note that 5 and 6 are not here, so they must be here on this row. The only two other values are 4 and 9, so those are from 4, 8, 9, and those are from 2, 4, 9. Seven is not in here, 7 is not in here. So there's no 7 in this T, but it has 5 and 6, so it must be digits from 2. It must be 2, 3, 4, 5, 6. 2 and 3 now are in here, so that's a 2. That's a 3. This is 4, 5, 6. 4 is not in here. 4 is not in there. And 9 is not in there. One goes here. This is from 7, 9. Those are from 7, 8, 9. What have I done? I've put a 1 in here. What am I doing? 1 goes there. So those are 7, 8, 9. But 8 is in here. One is around here, which means that we, on this row, 1 will be in one of two positions. But I'm thinking that this can't be possible, Because if I put the 1 here, then 2 and 3 must be in this T shape. They are not in here, and one of them is here. Only one of them could be here, so that doesn't work. So 1 goes there, that's a 2, that 2, that's a 1, that's a 2, that's a 4. What's this? That's a 1. And now with those 4s, we get a 4 in here. Not sure where to look next. This column needs a 2. So here, that's a 1-2 pair. This column needs a 4. It's not here, so the 4 is there. So that's a 4-7 pair. So there's no 9 in here. That's not 7. This is not a 5, so this is from 6 and 9. Wow, 4 and 3 don't look so inviting. By the way, that here can't be a 3. Okay, those 2s allow us to place a 2 here, so here that's not a 2. And by the way, this is 1, this is 2, this is 1. I think we've got all 1s and 2s in the grid. This is true. So now this doesn't contain 1 or 2, so it will be either from 3 to 7, from 4 to 8, or from 5 to, actually it contains the 4. So it could be from 3 to 7 or from 4 to 8, and it always contains 4, 5, 6, and 7. 7 is nowhere here, so we get the 7 in here. We need the 5 and the 6. 6 is not in here, so it will be in one of those 2 places. And it does not contain a 9, because 9 would be incompatible with the 4, so that's not 9. This is not 9, so in this region we get the 9 down there. So that this is 7, this is 8, this is 9, and this is 5, and this is 7, and it means that here we have the 7 and the 5. Those are from 6, 8, and 9. This 5 gives us the 6, the 8, and the 5, and the 6 here. Up there we need 7 and 8. This 3 goes there. Those are 4, 6, so that this is 5, this is 4, and the column needs an 8. Those are 5, 6, and 9, so this is from 5 and 6. This is from 6, 9, 5, 6, 9. That's a 9, by the way. And that's a 6, and that's an 8. This column needs 3 and 9, and there's already a 3 here. So 9 here, 3 down there, so that's not a 3 here. And it means that the 3 in the column is here. And it pushes the 6 into this cell, and that's a 9, and that's a 5. And here we need 4, 5, and 7. 5 can only be here. That's the 4, that's the 7. 5 is pushed into this cell. This is from 8 and 9. And this 5 goes there, and that's a 3. This 9 is not here. So we are nearly there. This 2 goes there. Here we need 4, 6, 9. 4 is here, that's a 6, that's a 9. Here we need 6 and 8. And that's a 9, which resolves all of this. 6 and 9, and 4, 6, 4, 7, 8, 7, and 8 and 6. And this is it. So that was really not easy. Really not easy. I may agree with the 105 points, to be honest. But this had a really nice logical path, and the fact that this digit sees all of them, this digit sees all of them here, is a really nice geometrical argument. I let you decide by yourselves. Alright, thanks for watching this video. See you soon on SudoKanard.